Hello everyone. So in today's video, we will be learning about open and close principle. This is the second principle from the solid and it's a very interesting one. So let's just dive in. So in previous video, we learned about the solid principles, the basics of it, the 5 key design principles, and why should we learn these principles, what happens if we do not follow it, and single responsibility principle. We also learned about some thumb rules to follow. And in today's video, we'll learn about the open-close principle. Now, what is this open-close principle? What is the definition for it? The definition says that a class or module should be open for any kind of extension, but closed for modification. Now, this can get confusing. So in simple language, if we say, it is that when you want to add a new feature, you should think about creating new classes or modules rather than modifying the existing classes or modules. I know this is not very clear here, but let's try to understand this using our example. Now, just to recall, we had our vehicle.py file, that is the vehicle class here, some initialization. We had insurance calculator file with insurance calculator class and calculate car insurance method there. We had object formatter class, and we also had seen that this was working in the main file. Like we just run it again, so it works perfectly. So that was the overall summary, but we need to make some changes here. So I see that in the insurance calculator, we are passing it vehicle, and then the name of that method is calculate car insurance. That doesn't seem right. So let's just go ahead and then change things here. And let's try to run this again. And we have to make changes here as well. Okay, this works perfectly. Now let's say in this code, you want to add more types of vehicles. So in this vehicle, it could have car, truck, or any other type of vehicle. So let's just introduce different classes for those. So let's say I create a class called as car, y, and let's just also create a truck.py. Now let's just go ahead and implement both of those classes. Let's just go ahead and implement car. So for that we'll do class car and then inherit from vehicle. And then I'll simply do a pass here, but it's actually showing me some errors. So I'll just import vehicle. Okay. Let me just copy this up and then paste it to truck. And I'll just simply rename this to a truck. Okay. That looks good to me. So now we have created classes for both car and truck, but let's go ahead and make sure that those changes are used in insurance calculator as well. So let's say we want to check if this vehicle is an instance of car. If so, we'll have some logic there, some logic of calculating the insurance for that car. And if it's a truck, we'll calculate it in a different manner. So let me move the age calculation beforehand and then have if is instance of vehicle is an instance of car, then simply return, I'll have it to return 1000 if the age is greater than 5, else 500. Similarly, I'll have an elif statement here, checking for is instance of truck, and if so, we'll simply return 1500. Else, let's say 700. Okay, let me get rid of this. And we also need to import car from car. Oh, I think I'm having import here. No worries. So similarly, we'll have truck import truck. That looks good now. Now, once we have all the changes in insurance calculator as well, let's just go ahead and check our main method, and we'll have to make changes here. So let's say I have a car initialized as, I'll basically use this one. Simply copy and then paste here. I'll also have a truck. Oh, it looks like I haven't imported those. So let me just go ahead and import those. Car, import, car. And similarly for truck. Okay, looks good. And then I think I misspelled it. No, that's correct. Okay. So let's just go ahead and then initialize this as, let's say, Ford. And then Ford F-150 is the most famous one. So I'll do that. And 2015 edition. Okay. Let me get rid of this vehicle here. Okay. Now let's move on to use those in the insurance calculator. And insurance calculator, vehicle, and then we'll have two print statements for both of those. Let's just do that. In one, I'll pass on the car, and in the second one, I'll simply have the truck. Okay, that looks good. Let's just go ahead and run that. Oh, looks like I haven't initialized this. Let's just change this to car. It should work perfectly. Okay, let me just clear this up so that it's visible. Okay, let's just run this again. Okay, so the car calculator is 1000 and this is 1500 and this looks correct. Let's just get rid of this one. And we are good to go. Now, after making those changes, we can say that we just broke the open-close principle. We had to introduce new features, in this case, car and truck, as a new vehicle. And in order to do that, we just modified our insurance calculator class here. We didn't add new things or new classes, we modified our existing class. So we broke open-close principle. Let's say somebody comes up and says that we need 4 different new types of vehicles. We'll need to add more if-elif statements here, and that would become ugly. Now, there are 2 things here. First thing is how to follow open-close principle and fix this code. And the second part is, why do we even care about following open-close principle? What were the consequences? What are the consequences for it? So let's do the first thing here. That is, fix this code to follow the open-close principle. And how will we do that? So for that, we'll have to go to the vehicle.python file here and then make some changes here and there. And here we'll have to import, let's say, from ABC, import ABC and abstract method. We'll convert this class, vehicle, to an abstract class. I'll make the changes and then probably talk about why we are doing it. And I think this can go well. Okay, this looks good now. Now, why have we converted our vehicle class to abstract and added an abstract method here for calculate insurance cost? So, first off, we have added this calculate insurance cost method here so that all of the subclasses, car, truck, bus, we ensure that all of these classes have to implement the calculate insurance cost. Otherwise, we'll see runtime issues. Why runtime issues? Because if somebody comes up and then goes into car and forgets implementing this, then we'll see a runtime issue. Now, why have we converted our vehicle to abstract class? This is because we don't want anyone looking at this code base to use vehicle directly. Rather, we should have multiple subclasses like car and truck, which are subclasses from vehicle, and we instantiate both of those. So let's say if we go to main.python, we don't want anybody to come here and just instantiate vehicle. That doesn't make sense, right? Let me just save this. So that is why we have our vehicle class as abstract. So let's just go ahead in the car and truck classes and then use this. So how will we use this? So we'll go ahead and just define our get calculate. I think calculate insurance cost, that's correct. And we'll just make some changes here. We'll go ahead and copy paste from the insurance calculator. And this might change to self. And we'll also copy paste this logic from there. And I think we should be good to go. We'll just simply copy paste it to truck. And we should make a slight change. Just copy paste here. And we should be good to go for the car and truck. Now moving on to our insurance calculator, we'll simply get rid of all of this and we'll return vehicle.calculate insurance cost. That looks good. We'll also get rid of both of these imports as we do not need any of those. And let's just save this and move on to the main method. So here we have instantiated car and truck and we have different prints. Let me just copy this for the truck or basically autocomplete there. Let's just try to run this now. Okay, that looks good. Our car insurance cost, I think I should probably move it to truck insurance cost. Let's just run this again. Let me clear this first. And then run this. Okay, so the car insurance cost is correct and truck insurance cost is also looking good and both of those prints are also good. So that basically tells us how open-close principle works. We have changed our code in such a manner so that we have a vehicle abstract class and then multiple subclasses which have specific logic for calculate insurance cost. Also, we got rid of all of the logic that was inside this if-else statement inside the insurance calculator. Now with this, we have understood what open-close principle is and how it works. Now let's move on to the second part on what happens if we don't follow the open-close principle. So if we go back here and look at what happens if we don't follow open-close principle, the first thing is adding new feature becomes chaotic. So for that, let's just take a look at our previous code. Let me just copy paste it here, all of this. So we had multiple if-else if statements here. So let's say you had more such classes like insurance calculator. There would be another class called as resale value calculator. So there would be another set of if-else statements like this. Whenever you create a new class, let's say bus or motorcycle, whatever, you'll have to first create that class. Let's say I go ahead and create a class called as bus.py. I'll have to make that class and then come back to all of these individual classes, let's say insurance calculator, resale value calculator, and add elif statements for them. Don't you think that's like too much? That's like very chaotic. And that is why we follow open-close principle and only make changes to the new class itself. Of course, this can't always be 100% of the time. It's not 100% accurate. But following this principle as much as possible keeps things organized. So that would be the first consequence. The second consequence would be modifying existing classes can introduce a lot of bugs. So let's just go into the example here. We had this code early on for the insurance calculator. Let's say I create another class for motorcycle. So for that, I'll go ahead and create a class here for motorcycle. and I'll have to come on to this class, insurance calculator, and add an elif statement. But what if I forget this part? I'll just simply add a class and then forget about making change here. In that case, we'll see error being thrown. So don't you think that's a bad design? So that is why we follow the open-close principle to not get into these ugly consequences. So once we have that, let's just look at some of the thumb rules that we can follow. Here I have added one of them, which is we should probably avoid these if-else statements. Like for example in this one, where we are checking for instances of vehicle as car and truck. So avoid these if-else statement where you are checking if a vehicle is an instance of car or truck. Rather, have a base class and multiple subclasses which have their own unique behavior. So let me just get rid of this. And as you can see, we had a vehicle class, and all of these car and truck are showing their unique behavior inside of these classes. That's what we want. So that's it for the open-close principle. I hope to see you in the next one where we'll discuss the Liskov substitution principle.